Okay, so when looking at these problems, it's important to look at the fact that all of the equations that we have here, whether it's the three variable or the four variable, um, e- each one is you're going to have two that are known and one that's unknown, and that one that's unknown is what you need to solve for. That's pretty much the way it's going to be with all of the equations here in chemistry. So why don't we start with this one here? Um, so c equals so the speed of light equals the frequency times the wavelength. Um, Speed of light, it's a constant. This will always be our speed of light. It will we'll always use that. Okay. Um, and look at the units here. This is important. Meters per second, right? Why that's important is because when we come down here to wavelength, we have to have our units in meters for this. Most of the time, we're going to have to change that unit then because meters isn't really something that's used too much when we're talking about wavelength, right? From the fingerprints of light lab, we had most of those were in nanometers. So you have to make sure that your units are always the same. So a helpful one with that is remembering that 1 meter equals 1 times 10 to the ninth nanometers. This one will probably be used more than once here. And then as we look at frequency, right? So frequency is just the number of waves that pass a particular point per second. So that's why when we look at our unit, it's per second here. Or another name for that is hertz. It's the same thing. Hertz or per second, same thing. Okay. Another way we could write that is it's just the reciprocal of seconds. So per seconds, right? So here's one equation that we could use. The next equation that we could use is when we're looking for energy, right? We'll be getting into this more in the next class when we're looking at the Pogel here and looking at how electrons move and the energy associated with those moves of electrons. So when we look at this equation here, energy equals, here's another constant. We will always use this as the constant, 6.626 times 10 to the negative 34th, and then we can look at our unit here, joule seconds, right? And then our frequency is the same as it was before in hertz, right? Our unit for energy here is joules. Um, The great thing about those two equations is we can also throw them together. Now, this was a mistake on my behalf. This was originally on the notes that I put online. It has changed since then, so you shouldn't see that one. You should see this one up here, right? So energy equals the speed of light times Planck's constant over the wavelength. Once again, very important here in meters. Okay. So let's look at a couple of these problems here. Let's do. Let's see, is this the one that I wanted? Yeah. Let's do this one first. Okay. A commercial microwave emits radiation from a or with a wavelength of 525 important millimeters. Right. Wavelength of 525 millimeters. What is the frequency in hertz of this wave? By the way, on the practice problems, those that are in parentheses, that's the answer to the problem. I want to give you the answer. Um, I want you to know if you did it correctly or not. Wavelength is what we're looking for. Or I'm sorry, wavelength is what we're starting with here. And we're looking for hertz. So when we look at those two equations, C equals frequency times wavelength is the one that we're going to use, right? So we know C. C is always 3.00 times 10. Sorry about that for the line. 8 meters per second, right? Um, Unit meters per second. We're currently in millimeters, so we're going to have to convert 525 millimeters to meters, right? Um, Before we can plug that in, right? So right now our wavelength is 525 millimeters. We want to convert that to meters. So to get from meters to or millimeters to meters, we need to divide that by 1,000 there to give us 0.525 meters. All right, now we've got a C, we've got a wavelength, so now we can solve for frequency. So let's just plug these in, 3.00 times 10 to the 8th meters per second. I always suggest keeping your units in the problem here so it helps you look at them and realize um, well, what number is what, right? It's a really good practice. So 0.525 meters. There we go. Um, Now we can just use algebra, right? Um, so we're going to divide both sides by 0.525 to isolate the frequency. So when we do that, after plugging that into our calculator, we have 5.71 times 10 to the 8th. And then when we look at our units, meters per second, and we're dividing that by meters, so we have then per second, or also hertz. I'm going to keep that with 3 sig figs because the only number that we have in our problem right here has 3 sig figs. So there's one problem. Let's do one more problem real quick. Let's do an energy problem. All right. A certain source emits radiation of wavelength 500 nanometers. What is the energy of a photon of radiation? Right. So um, we have two radiation or energy equations. Right. We have um, E equals Planck's constant times frequency, and we have E equals the combination of those two, right? C, speed of light, times Planck's constant over wavelength. Well, we have a wavelength, so I think we should use this one, right? So let's see, we've got our C. C is 3 times 10 to the 8th meters per second. We have Planck's constant, 6.626 times 10 to the negative 34th, 30, 34th joule seconds. And we have a wavelength. Our wavelength is 500 nanometers, right? Once again, meters, nanometers. We've got to get 500 nanometers into meters. So we are going to take 500 nanometers and we are going to divide that by one, sorry, divide that by 1 times 10 to the ninth. And that is going to give us 5.00 times 10 to the negative 7th meters. Now that we're in meters, we can plug all three of these into this equation. We're going to have energy equals the speed of light times Planck's constant over the wavelength. And when we look at all of these um, units, look, meters on top, on bottom, those cancel out. We're multiplying these two on the top, so we have per second, and we're multiplying it by seconds, so those cancel out. So that means our unit is left with joules, which is what it should be here. So stick that into our calculator, 3 times 10 to the 8th times 6.626 times 10 to the negative 34th. divided by 5 times 10 to the negative seventh. And I really highly suggest you just stick it all in your calculator at one time. Let it do that instead of you writing one number or putting a number in and then writing it down, putting another number in and writing it down and then dividing them. Just do it all. Just do it all at one time on your calculator. Learn to use the parentheses and such. If you want any help on learning how to use your calculator, come talk to me. I'd be more than happy to help you with that. Anyway, 3.98 times 10 to the negative 19th joules is our final answer. All right, if you have any questions on any of these or want to go over anything else, come see me.